Unlimited. That's the word that defines Starship's potential. And at the heart of it all lies the ever-evolving Raptor engine. For more than a year, we've been waiting for Raptor 3, the engine set to power Starship's first true orbital flights, and even lunar missions, expected to launch for the first time in early 2026. But if you think that's where the story ends, think again. SpaceX is already teasing something even bigger. The next generation upgrade we're calling Raptor 4, a new chapter in power, performance, and design. So, how powerful is it? What's new? And when will we see it fly? Let's find out, right here on today's Techmap episode. Alright, so here's the thing. 2026 is shaping up to be a huge year for Starship. We're talking about the first orbital flights, real payload missions, propellant transfers, and a whole lot more. And all of that is going to be handled by Starship's next big upgrade, version 3. This version will run on the Raptor 3 engine, and honestly, this thing is a powerhouse. It cranks out about 280 tons of thrust and uses what's called a full-flow staged combustion cycle. In simple terms, that means it's incredibly efficient, squeezing out every bit of performance it can. On top of that, it's been redesigned to be simpler and more reliable. It doesn't even need a heat shield anymore, which is wild when you think about it. Raptor 3 isn't just about power, though. It's built for reusability and quick turnaround, which makes it perfect for deep space missions where efficiency and dependability really matter. But here's the question. With all these improvements, should SpaceX take a breather? Stick with Raptor 3 for a while and focus on scaling up Starship operations? Well, if you've been watching SpaceX for any length of time, you can probably guess the answer. They don't stop. In late 2024, Elon Musk already hinted at what's coming next, Raptor version 4. So yeah, just when it seems like they've hit the limit, they find a way to push even further. That's SpaceX for you. Raptor 4 is about to take things to a whole new level. It's expected to break past the 300-ton mark, hitting around 330 tons of thrust. That's roughly 18% more power than Raptor 3. Pretty wild, right? Now, if Starship sticks with its current setup, a super heavy booster loaded with 33 Raptor 4 engines could pump out about 10,890 tons of total thrust at liftoff. To put that in perspective, that's more than 3 times the power of the Saturn V, the rocket that took humans to the moon. But here's where it gets even crazier. What if they tweak the design a bit and go for 35 engines instead of 33? Well, that total jumps to over 11,500 tons of thrust at liftoff. That's an almost unbelievable amount of power. In this upgraded version, Starship would also pack 9 sea-level engines and 3 vacuum engines in the upper stage, pushing the ship's total liftoff thrust to over 3,000 tons. That means it would come close to matching Saturn V's lift capability and actually surpass every other rocket in history, past or present. So yeah, the goal with Raptor 4 is pretty clear. Raw, unstoppable power. And that's exactly why, for Elon Musk, Raptor 3 was never going to be the end of the story. With Raptor 4 stepping up the thrust, Starship's whole game changes. It can carry heavier payloads and pack in more propellant per flight, which means better fuel economy on those long, deep space trips. In simple terms, that could translate to fewer tanker launches needed to fully refuel a Starship heading for places like Mars, or even farther out. To give you an idea, right now NASA's Artemis 3 mission is estimated to need around 15 Starship tanker flights to pull off a full refueling. That's mostly because the current Raptor 3 engines limit how much each tanker can lift. But if those tankers, or the Starship HLS variant, were upgraded to Raptor 4s with roughly 330 tons of thrust each, things change fast. Each flight could haul more propellant, cutting down the total number of launches needed. And it's not just about raw power. Raptor 4 is also getting smarter under the hood. the engine's efficiency has been improved through all kinds of refinements. Simpler design, higher chamber pressure, and better manufacturing methods like advanced 3D printing. The result is an engine that burns less fuel for the same performance. That means Starship would need less propellant in orbit to hit the same mission goals, which ultimately reduces how many refueling flights have to happen in the first place. Raptor 3 and the Raptor 4 vacuum variant will feature an oversized nozzle, which could reach a specific impulse of 380 seconds. Meanwhile, Raptor 3 is projected to hit a chamber pressure of 350 bar, already the highest of any operational engine. Raptor 4 could push this benchmark even higher. SpaceX's whole approach is built around iteration. They test, learn, tweak, and test again. Every flight gives them a mountain of data, and that data drives constant improvement. Over time, they've been able to strip away unnecessary sensors and parts because they understand exactly how the engine behaves. 3D printing plays a huge role here, too. It lets engineers build internal channels right into the engine structure itself, which means fewer external pipes and wires cluttering things up. You can really see this evolution from Raptor 1 through Raptor 3. Each version gets lighter, cleaner, and more refined, and Raptor 4 is absolutely following that same path. One of the biggest changes came with Raptor 3. The old heavy heat shield? Gone. Instead, the engine's been redesigned to handle high temperatures on its own. They moved a lot of sensitive parts inside the engine where they're naturally shielded from heat. That means fewer exposed joints, fewer covers, and less insulation needed. Under the hood, improvements in turbomachinery and the combustion chamber allow the engine to handle greater stress and higher temperatures. The cooling systems, which were already upgraded in Raptor 3, are getting pushed even further in Raptor 4. These systems are what keep the engine safe under intense heat and pressure, boosting both durability and performance. And here's the thing. By simplifying the design, SpaceX also boosts reliability. Fewer parts mean fewer potential failure points, and a cleaner layout makes it easier to build and reuse. That increased durability lets Raptor 4 run longer, sustained burns with less stress on each engine. The result? More efficient in-orbit refueling, fewer cycles needed, and smoother operations for deep space missions. Simplification doesn't just make things cleaner, it makes them faster and cheaper to build, too. Back when SpaceX was producing Raptor 1, each engine took about 11 days to make. Then came Raptor 2, and that timeline dropped to just 2 days, and eventually only 1. SpaceX hit that milestone in late 2022, and it's a safe bet that production speed has only gotten better since then. We don't have official numbers for Raptor 3's manufacturing rate yet, but here's what we do know. By May, the 20th Raptor 3 had already been spotted, less than a year after the very first one debuted in August. That kind of pace shows real momentum, and it'll likely ramp up even faster as production facilities expand. This rapid progress isn't just impressive, it's vital to SpaceX's goal of making Starship a high-frequency launch system. A simpler engine design means fewer parts to inspect, fewer components to replace, and less post-flight maintenance overall. And that directly translates to quicker turnarounds between flights. If Starship's going to hit full reusability and fly regularly, this kind of efficiency is key. Right now, the record for Raptor reuse stands at 3 flights with the Raptor V4 2-314 engine, but that's just the beginning. As new versions roll out and the tech keeps improving, we'll almost certainly see engines fly many more times before needing a full overhaul. All of this pays off in cost, too. Manufacturing, operation, and maintenance are becoming faster and more streamlined, which drives prices way down. Current estimates put a Raptor engine somewhere between $1 and $2 million, which is already low by rocket engine standards. But with Raptor 3, that could drop to around $600,000, or even $500,000 per engine. Combine that kind of affordability with high performance and rapid reusability, and it's clear why the Raptor family has become one of the most remarkable engines in the industry. To understand what makes Raptor 4 so groundbreaking, we need to look back at the evolution of SpaceX engines. Elon Musk and his team have always approached engineering like a strategy game. They treat every new version of the Raptor as a new round in that game, where lessons learned turn into immediate improvements. That mindset has allowed them to move faster than anyone else in aerospace. The Raptor 3 has already achieved an incredible level of performance. It produced around 280 tons of thrust, matching the record of the Falcon's Merlin engine in terms of thrust-to-weight ratio. But SpaceX did not stop there. The Raptor 4 pushes that number to around 330 tons. That is an 18% jump in power over its predecessor. When you multiply that across the 33 engines mounted on a super heavy booster, you get roughly 10,890 tons of thrust. If the design adds 2 more engines, that number breaks 11,500 tons of total liftoff power. For perspective, the Saturn V rocket that carried Apollo astronauts to the moon generated about 3,400 tons of thrust. The Raptor 4-powered Starship will produce more than triple that amount. It is raw, unstoppable power that completely reshapes what a rocket can do. This boost in strength means Starship version 4 can be bigger, heavier, and capable of carrying over 200 tons into orbit. The entire vehicle could reach around 150 meters in height. The upper stage alone grows by nearly 10 meters, expanding its pressurized volume and giving crews more room than ever before. In total, the crewed version of Starship version 4 could offer over 1,000 cubic meters of pressurized space, which is about 10% larger than the entire International Space Station. That means more space for equipment laboratories and life support, all powered by the next generation of engines. Now, power is impressive, but efficiency is what makes a rocket truly revolutionary. The Raptor 4 is not just about being stronger, it is about being smarter and cheaper. As Elon Musk recently revealed, Raptor 3 will probably be 2 to 4 times better than Merlin in dollar per ton of thrust, and will exceed Merlin in thrust-to-weight ratio. Raptor 4 should beat Merlin by over 10 times in dollar per ton of thrust, with further improvement in thrust-to-weight ratio and ISP. Raptor uses a full-flow staged combustion system, which is one of the most complex and efficient engine cycles ever built. This allows it to burn every drop of methane and oxygen as effectively as possible, squeezing out more thrust for the same amount of fuel. Elon Musk once admitted that he was not sure if a methane engine like Raptor could ever outperform the Falcon 9's Merlin engine. Merlin was simple, light, and incredibly cheap to produce. It dominated in both thrust-to-weight ratio and cost per ton of thrust. But those doubts are long gone. The Raptor 3 is already 2 to 4 times cheaper per ton of thrust than Merlin, and the Raptor 4 is expected to go even further, achieving a 10 times improvement in cost efficiency. Imagine getting 10 times more power for the same cost. That level of progress completely changes what is possible in space exploration. This leap is thanks to a design philosophy built around simplification and mass production. The Raptor 3 introduced a cleaner layout where most of its wiring, electronics, and plumbing were moved inside the engine. The Raptor 4 continues that trend, integrating everything into a tighter, more reliable system. It eliminates unnecessary parts, reduces weight, and cuts down on maintenance. Advanced 3D printing makes complex components cheaper and faster to build, allowing engines to roll off the production line at record speeds. These improvements are not just about cost, they make the entire rocket more reliable and easier to reuse. The future of spaceflight depends on reusability. To make space travel as routine as air travel, rockets need engines that can fly again and again with minimal maintenance. The Raptor V4 was designed exactly for that purpose. Each new generation of Raptor has become simpler, tougher, and easier to maintain. The heavy external heat shields are gone. Instead, the engine itself is built to handle extreme temperatures through its structure and materials. Sensitive parts that were once exposed are now protected within the engine's body, where they stay cooler and safer. This not only increases durability, but also reduces the time needed to inspect and prepare engines between flights. The current record for reusing a Raptor engine stands at 3 flights, but Raptor V4 aims to push that far beyond. The design changes make it possible to fly many times before a major overhaul is needed. That means faster turnarounds, lower costs, and more frequent launches. Production speed has seen the same dramatic evolution. When SpaceX built the first Raptor 1 engines, each one took about 11 days to complete. By Raptor 2, that time dropped to 2 days. By the end of 2022, SpaceX was producing 1 engine per day. The Raptor V4 is designed for even faster production and easier maintenance, turning what was once a slow, complex process into an efficient, continuous cycle. This speed is critical to making Starship the world's first high-frequency orbital system. The Raptor V4 is not only about power and cost, it also transforms how missions are planned and executed. Deep space missions like Artemis and future Mars expeditions rely on orbital refueling, where tanker versions of Starship transfer propellant to the main spacecraft in orbit. With earlier versions, NASA estimated that Artemis III would require about 15 Starship tanker flights just to refuel a single ship. That is a massive logistical challenge. Raptor IV changes that equation completely. Because it is more efficient, it burns less fuel to achieve the same performance. That means each mission requires less propellant overall. Combine that with Starship version 4's increased fuel capacity, and the number of refueling launches drops significantly. The new Super Heavy Booster version 4 will carry about 4,050 tons of fuel, an increase of 400 tons compared to the previous model. The upper stage will hold about 2,300 tons, 700 more than before. More fuel per flight means fewer flights in total. That simplifies operations, saves cost, and shortens mission timelines. Starship version 4 will also have 42 engines in total, including 3 vacuum-optimized Raptors on the upper stage. This gives it more power in space and greater flexibility during orbital maneuvers. With each upgrade, SpaceX is removing barriers that once made interplanetary missions seem impossible. The fewer refueling flights required, the faster and more efficiently missions can proceed. That is how Raptor IV brings the dream of sustainable lunar and Mars exploration closer to reality. Behind every leap in engineering is a way of thinking that makes it possible. Elon Musk approaches rocket design with the same mindset he uses when playing strategy games. His favorite Polytopia teaches resource management, strategic focus, and iteration. That mindset shows up in how SpaceX develops its technology. Each version of the Raptor engine represents a round of refinement. They learn from what works, fix what does not, and apply those lessons instantly to the next design. This approach turns failure into progress. Each test, each prototype, and each iteration leads to faster learning. The game, which Musk once called Polytopia Life Lessons, also inspires a powerful mindset: do not fear losing. You will lose, Musk said. It will hurt the first 50 times. When you get used to losing, you will play each game with less emotion. While most entrepreneurs avoid risk, Musk seems addicted to the challenge of it. SpaceX reflects that same spirit. The company has pushed its Raptor engines to their absolute limits, enduring hundreds of explosions during testing. Each failure taught them something new, and the results speak for themselves. They went from engines that once took weeks to build to producing one every single day. That pace of progress has never been seen before in aerospace history. It is also how they managed to create the world's most powerful and most cost-efficient rocket engine in less than a decade. Understanding Musk's obsessions with video games is a key to understanding his intensity, focus, competitiveness, die-hard attitudes, and love of strategy. And it's no wonder the billionaire lives his life as though he's constantly playing a video game. From making seemingly brash business decisions like the Twitter deal, to how he designs self-driving cars and rocket ships with little regard for safety, Musk constantly takes on huge risks with little concern for the consequences. For short, the Raptor 4 is not just another engine, it represents the next step in humanity's journey to the stars. With 330 tons of thrust greater efficiency and 10 times lower cost per ton of thrust than earlier engines, it redefines what is possible. It is the technology that could power NASA's Artemis missions and make Mars settlement achievable within our lifetime. Every piece of it, from its simplified structure to its rapid reusability, is built with one goal in mind: to make spaceflight affordable, frequent, and sustainable. It is an engine that will carry more payload, reduce refueling needs, and make interplanetary missions a regular reality. Elon Musk once said that making life multiplanetary is the most important thing humanity can do. The Raptor 4 is the machine that brings that vision within reach. It is not just about rockets. It is about a new era of exploration where humans become a spacefaring species. The countdown has already begun. The engines are ready. The next space race is not about nations competing. It is about humanity rising. And when those Raptor 4 engines ignite, they will carry us not only to the Moon or Mars, but into a new chapter of our story among the stars.